Okay, so our next topic is IUPAC nomenclature. IUPAC nomenclature. IUPAC nomenclature. See, in halide compounds, halogen is not a functional group. Halogen is a substituent. You have to remember this. Halogen is a substituent, not a functional group. Not a functional group. That substituent like methyl substituent, ethyl substituent, है ना, oxyhalide, oxyalkyl group, है ना? So it is just a like nitro group. So it is a substituent. It is not a functional group. Whenever we name the halide compound, we start with the halogen. See, like chlorine, bromine, iodine, and fluorine. They are pronounced as fluoro and chloro and bromo and iodo. Okay. So we will start with the prefix halide. है ना? We put the prefix halide like fluoro, chloro, bromo, iodo like this. है ना? Okay. I have written some examples are there. है ना? Like this. We have to name this structure, this and this. Starting with this. So you can start numbering from any sides. Huh? One, start with this side. Alphabetically, bromo will come first. So 1, 2, 3, 4, and 5. What will be the name of this compound? 2 bromo, 4 chloro. And we will first put the name of the halogen. After that, the main chain. So 2 bromo, 4 chloro, pentane. So the name of this compound will be 2 bromo, 4 chloro, and pentane. Next, this. For this compound, we will start the naming from that side where the double bond will be nearer. So we will start from the left side. So 1, 2, 3, 4, 5. So what will be the name? 4 chloro, 4 bromo, pent 2 ene. So the name will be 4 bromo, 4 chloro. We will write the substituent first and then the main chain. 4 chloro, bromo, 4 chloro, then pent 2 ene. Because in second position the double bond is there. Again from this, what will be the name? We will start from that side. This is the first carbon, then second, then third, and then fourth. So the name will be 1 bromo, 5 fluoro, 5 fluoro, and 1, 2, 3, 4. One ine, butane, or you can directly write it as butane. Okay. Now name of this compound. What will be the name of this compound? We will start from here. 1, 2, 3, 4, 5, 6. Okay. 2 bromo, 4 chloro, 2 bromo, 4 chloro, hex. 6 carbon are there, so you have to take hex. 1, 4, 1 comma 4, di. 1 comma 4 di. Again for this compound, Start numbering from this side. 1, 2, 3. Okay. So 3 methyl, 3 bromo, 3 methyl, 3 bromo, 3 methyl, or you can write it 3, this can be 4. So 3 bromo only there. 3 bromo, but 1 in butene. 3 bromo butene. So the naming will be here. 1, 2, 3, 4. 1, 2, this will be 3, this will be 4, this will be 5. So this will be pent. Pent 2 in. Okay, 3 bromo. 1, 2, 3. So this will become 4 bromo. 4 bromo pent 2 in. So this will be the name. Okay. So in IUPAC nomenclature, the first thing you have to understand that first we have to name the substituent. After that, we will name the main chain, and we have to start numbering from that side. If there is a double bond and triple bond, so we have to give the priority to the double bond and triple bond, and we have to start naming from that side only. Okay. So in haloalkane and haloarene, first we have to understand the nature of CX bond. Okay, one more thing you have to remember, haloalkanes, it means the halogen group will attach to the alkanes, that is carbon having single bond. Alright, so here carbon and halogen will form a bond, and this type of bond which formed between carbon and halogen, this is called, they are in polar nature, because as you know that the halogen is electronegative compound, so it will attract the electron of carbon, so it will develop a partially negative charge, and carbon will develop a partially positive charge, so it will show a polar nature. And this polarity will depend, this is also called, they will also form a dipole, they are forming the dipole, and as we know that the dipole moment will depend on the charge and the distance between. So the more polar nature, there will be more dipole moment. Okay, so dipole moment is basically depend on the charge and the distance between. Like if the halogen is fluorine, so for fluorine and carbon, as you know, the fluorine having maximum charge, but the size of fluorine is very small. In the case of chlorine, if the chlorine is forming bond with the carbon, so you know the chlorine is having the uh, lesser charge compared to the fluorine, but the distance is more. In the case of bromine, the charge is lesser, but the distance is more. And in the case of iodine, the charge is least, but the distance is most. So the dipole moment will follow this. Fluorine carbon will show the maximum dipole moment, then chlorine carbon, then bromine carbon, and last iodine carbon. So dipole moment depends on the charge and the distance between. So this is the nature of the halogen and alkane. Halogen and carbon, they form a polar bond between them. Again, there are, okay, next the effect of resonance on dipole moment. See, what is the effect of resonance on dipole? Effect of resonance effect of resonance on dipole moment. See, one thing you have to remember, the more resonance is there, the bond length will be decreased, so the dipole moment will also decrease, because dipole moment depends on the charge and the distance between. Dipole moment will also decrease. As I give you example, you are having a compound chlorine, okay, and one more compound is there. The same chlorine is attached to a double bonded, that is pi bonded compound. Now it will show the resonance. It will not show the resonance, but it will show the resonance. How? The chlorine will donate its electron to the this side, and this pi electron will shift toward this side. So this structure will become like this, double bonded chlorine, and this will form a negative charge. So this will show the resonance, and because of the resonance, the chlorine will form a partially double bond character. Here the chlorine and carbon are forming a single bond, but here the chlorine and carbon will form a double bond, and it will show a partially double bond character. Partially double bond character, and because of that double bond character, the bond effective bond length will be decreased, and because the bond length will be decreased, the dipole moment is also decreased. So whenever there is a resonance, the bond length will be decreased, and because of that, the dipole moment will also be decreased. So dipole has a inverse relation with the resonance. Okay. Alright. So this is the effect of the resonance. Next, there are two types of element or species. First is nucleophile species, and second is electrophile species. Electrophile. Nucleophile species are also called electron lover, and electrophile is called electron hater or nucleus lover. This is the nucleus lover. Nucleophile means, sorry, phile means lover, means it is nucleus lover. Nucleus means what? Positive lover. And this is the electron lover, that is negative lover. That is negative. So in nucleophile, the elements or species having the negative charge, like cyanide, chloride, bromide, fluoride, OH minus. Okay, so they are species, nucleophile species, because they will get attracted toward the nucleus, that is positive. And electrophiles means electron lover. The element having a positive charge means H plus, NO plus, and anything carbocation, C plus. Okay, so anything having a positive charge, they will attracted toward the electron, so they will called electrophile element. Okay, so these are the main compounds, nucleophile and electrophile species. Where we move forward in this chapter, we will study about the types of reaction. In types of reaction, we will learn about the substitution, nucleophilic and electrophilic reactions. So in that reactions, we will learn about the nucleophile and electrophile.